Let's talk about singly linked list. Now we have two sorts of linked lists, doubly linked list and singly linked list. Because it's easier to discuss singly linked list, we will first talk about singly linked list. Now, what's a singly linked list? Well, it's a list of nodes in a list with a head, and the tail is basically like points to null. Basically every node has a value. Like imagine to have an array of 1, 2, 3 as a singly linked list. This one is a node, this 2 is a node, this 3 is a node. But every node has a value, so 1, 2, 3 or 100, 125. It has a pointer as well. Now the pointer points to the next node. So the first node, the one that nothing points to it, is the head value. It basically has a value and a pointer pointing to next. The last value, the last node, node 4, has a value and a pointer which points to null. And this is all about linked lists. Like singly linked list is a set of nodes, basically values with a pointer. They point to each other until the last one points to null. Okay, so why this? Well, because arrays are in contiguous places in memory. Basically, they are side next to each other in memory. But linked lists, because of the concept of pointers, you could basically have a memory like this on a computer with thousands of places, and you put something here on this corner, something on this corner, then in between there are other things. So basically they are not at contiguous places in memory because they have pointer which points to a place in memory of the next one. You don't need to put them in a contiguous place in memory. Dynamic size, you don't need to set size. In arrays, you have to set size. Of course, in JavaScript it's dynamic because the language dynamically like puts the size by itself, but arrays are not dynamic in size. But the concept of pointers makes this to be dynamic in sizing. It's very efficient to insert and to delete. So if you want to put something like insert something between 150 and 188, you basically point your pointer to the new node and the new node to this 188. So insertion and deletion are easier. In case of arrays, like you have to move the entire array like from side to side. So that makes it more efficient, linked list more efficient in terms of insertion and deletion. As we spoke about, it's a flexible memory allocation. So basically we can, since we have dynamic sizing, we can have a flexible memory allocation. We can store wherever we want. This is foundational for the implementation of other data structures because we have things like node traversal. Basically, we will discuss later how we traverse from one node to another and how we use pointers or two pointers. So if you learn linked lists, honestly, like it will be foundational for some of the drawbacks is like sequential access, so you don't have sequential access like you have in arrays. You also have additional memory overhead because, as we said, any node in linked list not only has a value but also has a pointer. So what we create here is a linked list class which we will be able to insert first, insert last, insert at a specific position, delete by value, and display. So what we do here, we create two classes. Class node, this is for the nodes, is a constructor which has two arguments. One of them is data, one of them is next. This data is equal to data. So data is whatever the user provides. This next is equal to next. So next is whatever the user provides as well, but we provide the default value for next, which is null. So this is an example of our node. Here we have a node which has a value or data, and it has next, which is pointer. Then we create another class called linked list, which has a constructor, and the constructor this dot head is equal to null. So linked list itself is like this big giant list. It has to have head, which at first is null, and it uses like the node constructor to build things. So let's do the first operation, which is insert first. So insert at the beginning of the array, of the list. So insert first takes data for value, and this dot head equals to new node. Now we use this class node to build a node. This class takes data and takes next. Here we say data is whatever the data is provided, and this dot head, this refers to this class head, is equal to the head, which is null for now. So this is basically like if we do const linked equals to linked list, new linked list, and we provide the data as hello, and if we log the linked, we see, let's see what we have. Sorry, at first we just announce, then we say linked dot insert first hello, and if we do this, we see we have a linked list. The head is a node with hello and the next to null, which is exactly what we want. So insert first an operation is completed. How about insert last? Insert at the end of the list, insert last. It takes data just like insert first. Const new node equals to new node. Basically we use the same node class, and the data is just data. We have a new node, we haven't pushed it anywhere, now we have to push somewhere. Now it's time for checking. If this dot head, so if we didn't have head, if it was null, then this dot head equals to new node, and we are returned. So basically if we didn't have anything in the linked list, we just put it in the first place. But you might say like, well, we have insert first. Insert first is used even when the linked list has items like hello. Now we can try this. We can make by to see if by is now first, just to see. So we see head is now by, and the next or the pointer points to hello. So insert first, even if it's not like null, it points to it makes something in the beginning of the linked list. But insert last creates a node. If the linked list is empty, puts the node in the head. Otherwise, what it does, we say let current equals to this dot head. So if the node wasn't empty, then the current should be the head of the node. Okay, so now we have the head. While current dot next, so long the head has next, so long it doesn't point to null, current is equal to current dot next. Now current dot next equals to new node. Now what does this do? Well, this says, as we said, like if there was nothing, put it in the head, otherwise current is head, while current dot next is not equal to null, make current dot next. So go to the last place, so long it's not equal to null. Then make current dot next our new node. So basically the last item which points to null will be our new node. Now our new node is at the last place now, and it points to null. I hope you understand this, because this is so foundational. This node traversal, this is pointer. So let's say linked dot insert last morning. And morning is now okay, there is something horribly wrong here. Okay, so this is the problem. Sorry about that, but things like this happen in programming, and we have to be able to troubleshoot. So at first we have by, which points to next, which is hello, and points to next, which is our morning, which points to null. So now insert last works just as insert first. Now let's talk about insert at a specific position. Insert at a specific position. For this one, insert at, we have data, we have position, which is set by the user. If position is equal to 0, or this dot head, again it's a mistake, this dot insert first, data and return. So basically, if our position was 0, which means the beginning of the array, or we didn't have a head, just use the insert first. Just use this function to put it in the first place. So that's, we checked like if the array is empty or the position or is 0. Const new node equals to new node. Now we did this operation again and again, so I hope you get this one. Now we create pointers. One pointer is current, which equals this dot head. Now pointer is just a place in memory, which now this current place in memory is the head of this linked list. So we have a pointer to the head. We want another, let prev equals to null, let count equals to 0. So we have this pointer, we have prev pointer, which now is null. So we have two things between current and null, and we have a count, which is a variable. Now we traverse. Traverse means just something like looping. While count, let's say count is 0, is smaller than position. Let's say position is 2. While count is smaller than 2, and current has next. Current is head, while current has next. So if it doesn't point to null and the count is bigger than 0, smaller than 2, let's say, prev is equal to current. So we basically update the previous from null to current, and current is this dot head. So current became head, prev became head, and current becomes current dot next. And current moves one position here. So we have current here, we have prev here, prev goes here, current goes here. So it traverses as long as our count is smaller than the position provided. Count plus plus, we increment the count by 1 so long position count is smaller than position and current has next. We set prev to be current, we set current to be next, and we set count to be count plus plus. Now new node, which we created here, dot next equals to current. New node dot next equals to current. So what does this do? This goes through the loop. When this is all updated, previous equal to current, current is equal to current dot next. So it finds basically, like, let's say we want to, it finds 2. And it says like new node dot next should be current, because current points to 3. So we want our new node to point to 3. Now what does we do with 2? We set it like this. If we have prev dot next equals to new node, else this dot head equals to new node. So basically, if we have previous, it should point to our new node. So what we did, according to a position, like let's say we want to put an array here. What we do, we loop through the linked list and we say like, okay, when you found node 2, set this to point to, let's say this is our new node. Set this to point to, if I can, like, to point to here, and if we have previous, point to our new node, otherwise make our new node head, because if you don't have previous, then our new node is head. So this is traversal. This is a bit difficult to understand, to be honest, for me as well, as I'm learning, but I hope the explanation like give you an idea about how this works. Now let's talk about delete node by value. So delete node by value. Delete by value takes data and it says if this dot head, if we don't have head, then just return because there's nothing to delete. Otherwise, if this dot head dot data is equal to data, then this dot head is equals to this dot head dot next and return. So basically if head was alone, then just point to null, remove it, point to null if we have only one thing. If not, so you have more than one, let current to be assigned to this dot head. Again, we create a pointer. Let prev equals to null. So it's very important to learn to create pointers and traverse linked list because we will need it in tree traversal, in others, graph, things like that. So we say while we have current, so while we have this dot head and current dot data is not equal to data, so long we have current and current dot data is not equal to data, prev is equal to current, current is equal to current dot next. Basically move along the line. Basically current is head, prev is null, while we have current, so head, and current dot data, the value of current, is not equal to data. Make previous the current and make current the next. So basically we traverse through the linked list. If there is no current, just return, else prev.next equals to current.next. So what we do here, we traverse through the linked list to find the specific list, a specific node that we want, and we go through it. If there was no current, we just return. If there was, for example, we look for 2 to find 2. So if there was 2, make prev.next to current.next. So make one pointer of 1 to go to 3 instead of 2. Basically, we jump over node 2, and that means we remove it from the linked list, something like this. And if we do display, for example, this is just for showing the values. We say let current, another pointer, equal to this dot head. While we have current, if we have head, console.log current.data, then current is equal to current.next. So now if we do, if we do linked.display without logging it to the console, we should see something exactly like by hello morning. So this is display. But if we do, for example, so if we do linked insert at the position of the value is howdy, the position is 2, and let's just log our list instead of display. We already tried display. Let's see where is howdy. So we have a linked list with by, which next to hello, which is next to howdy. So at the position of 2 now we have howdy because we said put it in the position of 2 with the value of howdy. So let's try delete. Linked delete by value, and the value we will do hello. Let's try also do by, so we should have only morning and howdy left. And let's do this to see. Now we have howdy as a head, and next is morning, which points to null. Thank you very much.